Welcome to a quick review of the Apache Spark integration in IBM dashDB Local. dashDB Local is a combination of a relational data warehouse engine for BI and OLAP type data processing with Apache Spark for more advanced and flexible data processing and machine learning. So let's review a couple of the benefits and new options that this opens up for you. Let's start with the out-of-the-box ability to explore your data interactively using notebooks and using the scalable Spark computation environment and all of these rich libraries for data exploration and visualization. But not only data exploration, as a data scientist you can also go further and do interactive data science using predictive analytics algorithms and machine learning libraries that are available with Spark, such as Spark ML or such as SystemML. And at the same time, dashDB provides you the mechanisms to go the next step and take what you just created as a data scientist and deploy it for an operational use in an application environment. So this means dashDB Local is also a hosting environment, a scalable, secure and multi-tenant enabled hosting environment for your Spark workload. Instead of writing and deploying your own Spark-based applications in dashDB, you can also use one of the pre-packaged Spark-based machine learning algorithms that you can access through a SQL-based store procedure interface. This is just a consequent continuation of the proven in-database predictive analytic routines that dashDB originally inherited from the teaser. Just that now we are using Spark instead of a proprietary implementation of algorithms. But Spark is more than just machine learning. You can also use it to do complex data transformations or data extractions in a scalable way. And in the context of a data warehouse like dashDB, this basically means ELT. So with Spark now in the box, you are not limited to SQL anymore to do data extractions or transformations in the data warehouse itself. Another new option that is at your hand is to create a Spark application that consumes data in motion from streams using Spark streaming, and use that application in order to directly land this data in your data warehouse automatically and in an ongoing way. And in a similar way, you can use Spark and create an application that reads data from other data sources, such as cloud data in object storage, for instance in Amazon S3, and do this with using an optimized object store connector in Spark, read it in parallel, and then load it into your data warehouse using your parallel Spark application. And finally, I want to point out that the support for Spark, of course, also includes the support for writing Spark jobs in Python using the PySpark API. But as a bonus, this also includes the ability to write any kind of Python script and run it in dashDB using a REST API. I hope this overview of new possibilities made you curious, so please come back and check out the more detailed tutorials for each of the individual possibilities.